Electricity is a very important topic in science paper 1, which is physics. So if you have never understood electricity, I encourage you to check out my video that talks about the entire calculation when it comes to the series connections, resistance connection, and also both in parallel and also in series. Well, if you haven't subscribed, subscribe so that you can be able to receive more information from us, Radical Academy. Thank you so much, and I would like to welcome you once again. This is Radical Academy, and my name is Wada Mike. In this video, I'm going to answer this question, which is from 2023, last year, in 10 of grade 12, and this is Physics Science Paper 1, and on the topic electricity. So this is question 7 that we're going to solve. So just pay attention and get your paper, plain paper, and also pencil and calculator, pen and pencil, so that you can solve it together. Okay, so the first question says, B7A, what charge is acquired by material that loses electrons by rubbing? Okay, so what you need to understand is that part of the question is coming from what is called the static electricity, where just the charges are within a material. We can talk of a metal or even a non-metal. But when you're looking at charges, there are only two types of charges. So we have the positive, okay, the positive stroke, the negative charges, okay. So in this question, what charge is acquired by a material that loses electrons by rubbing? So when the material loses electrons, okay, loses electrons, what just happened is that the electrons which are negatively charged, okay, they are the one that moves out, okay. So what only remains are the positive charges, okay. The positive charges are the one that remains. So on this one, the answer is simply positive charges, okay. It is just the positive charges, okay. B, give one natural occurrence of a static electricity. So when you're looking at static electricity, so you can just talk about when you step, it occurs or it can happen when you just walk, okay? When you walk across, a carpet, okay, let's just say a carpet floor, and then touch a metal doorknob, okay. Okay, so that you can also get some static electricity there. And then you also, maybe just to give you another one, you can also talk of let's say during ironing, okay, when you ironing of clothes, okay, static electricity can also happen, okay. That's how you can just respond to this question. Okay, and then we have figure B7.1, that is question C. Shows a circuit diagram with 3 different resistors connected to a 24-volt supply. So you have this one. Now, when you see this kind of sort of diagram, which is a circuit, okay, you have these resistors, and then the other one that is connected within just this original line, because it doesn't have any other direction. But when you look at these two, when you come here, it goes here, and then it also comes to the 6 ohm resistor and also to the 3 ohms resistor. So this is parallel. So the 3 and 6 are in parallel, while this 2 ohm resistor is just in series. Okay, so now let's answer this question. So it says define. So define resistance. So this is the opposition to the flow, okay, to the flow of electric current. Okay, so you can just be more specific. Electric current. Okay, so that's the answer. And then you go now to 2. Okay, 2. Calculate the total resistance. So when you look at the diagram, okay, when you look at the diagram, the most important thing to understand is that when you have something like the parallel and also the series, okay, first of all, you have to find the combined resistance for the 3 and 6 ohm resistors. So what you do there, you just say in parallel, there is a formula. It's 1 over R. Okay, so 1 over R, for example. Okay, so you're going to say 1 over R1. So we're going to call R1, 3 as R1 plus 1 over R2. Okay, so you can have as many as not just on 2, but you can even have 3 or 4. So your R1, okay, R1 just 3 ohm, and then R2 is just 6 ohm resistor. So now from there, what you can do is simply saying that replacing, so 1 over, sorry, okay, just it's 1 over 3, because R1 is just this, plus 1 over 6. So R2 is this. So what you do there is that you find the lowest common denominator, and then there you are coming up with R1, 1 over R1, just 1 over R, 1 over R, okay? So from there, the lowest common denominator, okay, so the number in which 3 and 6 can be divided into is just 6 itself. So 3 into 6 is just 2 multiplied by 1, just 2. And then plus 6 into 6 is just 1 multiplied by 1 on top, just 1. Then from there, you can now say it's 2 plus 1, just 3 over 6. And then now, this is 1 over R. So once you reach there, you can just cross multiply. So this is going to be 3 R. Okay, 1 times 6, just 6. So you divide both sides. Then our resistance across the 6 and 3, then the combined is just 2 ohms. Okay, 2 ohms. Okay, so the 2 ohms. Okay. Now the total now, okay, so total resistance, so the total resistance, so RT is going to be Now this one plus the 2 that you have found. Okay, so this 2, okay, is going to be this 2 ohms plus this one that you have found for the parallel one. So 2 ohms, and this is going to be, this will just be 4 ohms. Okay, so that is a total resistance. Okay, now let's move on. Okay, so we have answered this one. Then now the last question is saying, what is the current in the circuit? Okay, so by that they mean the current that is flowing and is also measured, or rather just recorded by this ammeter, which is the instrument that measures the current. Okay, so on this one, so what you're going to do is current, we know for us to find, or rather to answer question C3, I think that's C3. Okay, so we are going to use Ohm's law. You know that Ohm's law is that R equals to V, okay, over I. Okay, so we know that our R is 4, okay, 4 ohms, and our V from the diagram, we know that the voltage is 24, okay, and we are going to write like that, 24 volts. Okay, and now the I is what we are looking for. So the I, we put a question mark there. So from there, by replacing, so there is R, we put 4, okay, equals, on V we put 24, and then over on I, just leave it like that. Then from there, just cross multiply, meaning 4 times I, just 4I, equals 1 times 24, just 24. Then we divide both sides by 4. Divide both sides by 4 because we want to remain with R. This goes. So our I, which is the current, equals to, so once you divide, we are going to have 6 amps. Okay, so therefore current, which is in amps, or should I say I, okay, which is I, is equal to 6 amps. Okay, so that is the answer. So thank you so much for watching, and I will see you in the next video. Remember to subscribe to my channel for more information.